Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Before we start our lesson, we will begin with reciting surah. The first one will be Surah Al-Fatihah, Surah Taha ayat 1 hingga 5, Surah Al-Insyirah, Surah Al-Kafirun, and then Surah Al-Ikhlas by 3 times. After that, followed by selawat ke atas Rasulullah sallallahu alaihi wasallam. Kita niatkan selawat kita ni untuk memenuhi perintah Allah Subhanahu Wa Taala. Kita niatkan selawat kita ni untuk memenuhi hak Rasulullah Sallallahu Alaihi Wasallam. Kita niatkan selawat kita ni untuk mendapat syafaat Rasulullah Sallallahu Alaihi Wasallam di akhirat kelak. Dan kita niatkan segala bacaan surah dan selawat kita ni untuk kedua orang tua, keluarga dan seluruh umat Muhammad Sallallahu Alaihi Wasallam. Kemudian doa sebelum belajar, semoga dengan usaha ini akan membantu pelajar agar mudah memahami dan dibukakan hati para pelajar untuk mencintai ilmu. Okay?
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم
الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين. بسم الله الرحمن الرحيم طه ما أنزلنا عليك القرآن لتشقى إلا تذكرة لمن يخشى تنزيلا ممن خلق الأرض والسماوات العلى الرحمن على العرش استوى. بسم الله الرحمن الرحيم ألم نشرح لك صدرك ووضعنا عنك وزرك الذي أنقض ظهرك ورفعنا لك ذكرك فإن مع العسر يسرا إن مع العسر يسرا فإذا فرغت فانصب وإلى ربك فارغب. بسم الله الرحمن الرحيم قل يا أيها الكافرون لا أعبد ما تعبدون ولا أنتم عابدون ما أعبد ولا أنا عابد ما عبدتم ولا أنتم عابدون ما أعبد لكم دينكم ولي دين. بسم الله الرحمن الرحيم قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد. بسم الله الرحمن الرحيم قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد. بسم الله الرحمن الرحيم قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد.
اللهم صل على محمد وعلى آل محمد 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 محمد اللهم صل على محمد وعلى آل 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 محمد
Doa sebelum belajar. Bismillahirrahmanirrahim. Allahumma aftah alaina hikmataka wanshur alaina min hazaini rahmatika ya arhamar rahimin. Ya Allah, bukakanlah ke atas kami hikmat-hikmat-Mu dan limpahilah ke atas kami khazanah rahmat-Mu. Wahai yang maha pemurah lagi maha penyayang.
Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Ya Rabbku, lapangkanlah untukku dadaku dan mudahkanlah untukku urusanku dan lepaskanlah kekakuan dari lidahku, supaya mereka mengerti perkataanku.
Amin.
Amin, amin, amin. Ya Rabbal Alamin. In this session, we will discuss about topic 1.9, properties of numbers and sequence. So, can you please get ready with your notes, page 56 until 67. And worksheet page 56 until 63. We're going to cover 4 subtopics. The first one will be 1.9.1 triangle numbers. The second one 1.9.2 linear patterns and integer sequence. 1.9.3 generating terms of a sequence. And last one 1.9.4 generating sequences from practical context. Now, let us start with 1.9.1 triangle numbers. Objectives. At the end of the lesson, students should be able to explain and recognize the sequence of triangle numbers. And our S2S, our steps to success. First, explain triangle number sequence. Second, explain and which stated the number of terms in the sequence. N is actually the number of the terms in the sequence. And the last one, use the rule Tn equal to n bracket n plus 1 divided by 2 to calculate any triangular number. You need to memorize this formula, okay? And this formula is used to find out, to calculate the triangular numbers. And don't forget to copy all of this S2S into your notes. Okay, triangle numbers is the representations of the numbers in the form of equilateral triangle or right angle triangle, which arrange in a series or sequence. This is the triangular number sequence. We have 1 for the first term, second term 3, third term is 6, 10, 15, 21, 28, 36, and then 45. And it is simply the number of dots in each triangular patterns. Now, n is the number of the terms in the sequence. Okay, for the first term, which is this one, and the number of dots is 1 dot. And if we change it into triangular patterns, it will be like this. And for the second terms, which is here, we have 3 dots. Okay, and when we represent in triangular patterns, it will become like this if it is in equilateral triangle, and if it is in right angle triangle, it should be like this. Okay, 3 we have 6 dots, 4 we have 10 dots, and 5 we have 15 dots. Now, by adding another row of dots and counting all the dots, we can find the next number of the sequence. The first triangle has just 1 dot. The second triangle has another row with 2 extra dots, making 1 plus 2 equal to 3. Okay, the third triangle has another row with 3 extra dots, making 1 plus 2 plus 3, which is 6. The fourth has 1 plus 2 plus 3 plus 4 equal to 10, and so on. You can also use this method to know the terms in the sequence for triangular number. Alright, but you have another method which is applying a formula, which we're going to cover on the next slide. As I mentioned earlier, there is another way to calculate the triangular number, which is by applying rule. And rule means formula. Okay, for this sequence, we will use the word rules instead of the word formula. Alright, and here is the rule. Here is the formula of finding triangular number, and you need to memorize this formula. Alright, and Tn means dots in triangle N. Okay, now proceed with example 1. How many dots in the 20th triangle? And why you need to remember this formula? Because sometimes the question is like this, right? How many dots in the 20th triangular? It is time consuming for you to calculate from the first term until the 20th terms of the triangular numbers, correct? So in the other efficient way to calculate, to find out the the total number of dots, is by applying the formula. All right, now, and this 20 is the n. All right, so we substitute that n into 20, right? And then we solve, and you should get the value. And how many dots in the 20th triangle? The answer is 210 dots. All right, now for example 2, I will give you 1 minute to try. Okay, now how many dots in the 60th triangle? You apply the rules, and then you change n into 60 and you solve, you should get the final answer. Be careful with your calculation. Okay, and the final answer for example 2 is 1830. Now, example 3, you are stacking logs. There is enough ground for you to lay 22 logs side by side. Okay, how many logs can you fit in the stack? Okay, this is the example in which the triangular numbers are playing in word problem. Okay, so what is that 22? Okay, I give you 1 minute to try. Okay, now, so solution, you still use this formula, okay, to find out the number of logs that you can fit in the stack, okay, and that 22 is the n, okay, that 22 is the n. So you change n into 22, you substitute that you substitute that 22 into that n, and then you solve, and then you should get 253. The final answer for example 3 is 253. Now, next example, the last example for 1.9.1, example 4. By using the rule Tn equal to n bracket n plus 1 divided by 2, list the first 5 triangular numbers. Okay, and you need to use this rule to get the first 5 triangular numbers. Okay, and it is not impossible for you to encounter this kind of question in exam, so you must know how to use that formula. All right, now I give you 1 minute to complete these first 5 triangular numbers. Okay, now for the first term, you change that n into 1. So apply the formula, then you should get 1. Then for the second term, you change that n into 2, and you should get 3. The third term, you change that n into 3, and you should get 6. The fourth term, you change n into 4, and you should get 10. And the fifth terms, you change that n into 5 and you should get 15. Therefore, the first 5 triangular numbers will be 1, 3, 6, 10, and 15. the final answer for example 4 will be 1, 3, 6, 10, 15. Now, moving on to 1.9.2, linear patterns and integers sequence. Learning objectives. At the end of the lesson, students should be able to describe and continue linear growing patterns and sequence of integers. And actually, the sequence of integers, you already learned some of it during your year 6. Okay, so this is the continuations of your sequence from year 6. All right. And S2S, our steps to success. First, identify linear sequence and applying rule UN equal to dn plus C. This is the second rules that you need to memorize for sequence. Okay. And then construct linear sequence rule by by answering all the question given. And the last one, describe different patterns of sequences of integers. And don't forget to copy this S2S into your notes. First, linear sequence, linear patterns. A linear number patterns is a sequence of numbers whose difference between all the terms is the same. How are you going to recognize that sequence is a linear sequence? When you find out the difference between all the terms is the same. Okay? And then the general rules to find linear patterns is UN equal to dn plus C, which UN is the n terms, D is the common difference, C is the constants. Constants mean a number. Okay, in maths, constant mean number. All right, so you need to remember this formula, and this formula is linear patterns formula. Okay, and then integer sequence. An integer sequence is a sequence of integers. It can be diversified. Okay, it can be diversified, this integer sequence. Sometimes it's about square number sequence, cube number sequence, and so forth. Now, example 5. Start the rule for this sequence. Okay, in exam, how are you going to know the rules? First, you try to find out the difference between the terms. Okay, so here, you try to find out the difference between the terms, and here we have plus 6. Okay, the difference is plus 6, and the next one plus 6, and the next one still plus 6. So by now you should know this is linear sequence. Okay, if you confident this is linear sequence, then you can apply this formula UN equal to dn plus C. And then you apply the formula UN equal to different is plus 6, correct? So you change the D into 6. Okay, the difference is 6, so you change into 6. And then the next step, as the first term is 7, we can write down the equation. Okay, now for this UN, you can take any of the values here. Okay, and the most easiest way, you take the first term's value. Okay, this first term's value we call it UN. Okay, so that UN I change into 7 equal to 6n plus C. And for this step 2, we're going to find out that C. Okay, but here we have two unknown. The first one is n, the second one is C. That means if you encounter this problem in exam, that means you miss one information. Okay, now we miss this n. When we take that UN equal to 7, that means we take the first term's value, correct? Therefore, the terms for 7 is 1. Alright, so 7 is 7 equal to 6, bracket 1 plus C. So here we already have one unknown. We proceed. You should know why here is 7 minus 6. And C, the answer is C equal to 1. Do not stop up to here. Okay? Because the question want the rules, not the value for C. Therefore, balikkan semula. Okay, the original formula, but you just change that D into 6 and that C into 1. Therefore, the rule for the sequence is UN equal to 6n plus 1. Okay? Next, example 6. For the sequence 2, 7, 12, 17, 22, 27, for part A, you need to state the rule for the sequence, so you need to find the rule. And for part B, you need to write down the next two terms. I will give you 1 minute to try. Okay, now for part A, it's same like example 5. Okay, and again for sequence in exam, before you know which kind of sequence that you're going to solve, okay, you try to figure out the difference between the terms. Okay, so here the difference is 5 and they have common difference. When they have common difference, that means this sequence is linear sequence. Then you can apply the rule UN equal to dn plus C. Okay, so UN equal to dn plus C. So I'm using the first term here so 5 is the difference, n equal to 1, y1 because I'm taking the first term plus C, and in this step I'm trying to find out the value for C. Be careful with your integers, alright? And here I removing this 5, so minus 5 for both sides. That is why here C equal to 2 minus 5 and C equal to negative 3. Why negative 3? Because in front of bigger value here is negative, and you should write down the negative. Do not stop up to here. Your final answer should be UN equal to 5n minus 3. You just change the formula for D and C. And the rest of it, just copy it down. UN equal to 5n minus 3. Okay, write down the next two terms. In this situation, you can continue by applying plus 5 to find out the next term like this. Okay, so the next two terms will be 32 and 37. And this will be your method 1. Or for method 2, you use your formula here, you get here, and you just substitute that n into 7. Okay, why 7? Because we are going to find out the 7th terms here. First term, second terms, third terms, fourth terms, fifth terms, sixth terms, and seventh terms and eighth terms. We're going to find out the value for 7 terms and 8 terms. Okay. So for 7 terms, we already get the value, which is 32. And for term 8, we got 37. Therefore, the answer is 32 and 37. Next, for example 7, for the sequence 7, 11, 15, 19, calculate the difference between successive. Successive means following in order terms. Okay. For part B, determine the rules that generate the sequence. I give you 1 minute to try. Okay, now for part A, calculate the difference. So 11 minus 7 is plus 4. We need to put either plus or minus. Okay, that is very useful for you to apply if you finding the rules. Okay, so if it is plus 4, you write down plus. If it is minus, you write down minus 4. Things like that. Okay, so 15 from 11 to 15 it is plus 4, and from 15 to 19 it is plus 4. So calculate the difference. The difference is 4. Okay, and rules, since here you can see that the difference are common, are same, therefore this sequence is linear sequence. You can apply that formula of finding the linear sequence. Okay, so first find C, and here I'm choosing the first term here, so I put the UN as 7, N is 1, and the difference is plus 4. That is very important. That is why it is very important for you to indicate it is plus or minus. If it is minus in these rules, you should write down minus also. Okay, so I got C as the unknown. 7 equal to 4 plus C, and here I need to remove that 4, so minus 4 both sides. C equal to 7 minus 4, and C equal to 3. Therefore, your rules for the sequence is UN equal to, don't forget to change that D into 4, and don't forget to change that C into 3. The rule is 2n equal to 4n plus 3. Okay? Next, example 8. One number is missing from the following sequence. So, for part A, write in the missing number. For part B, calculate the difference between successive. Again, successive means following in order. Okay, so calculate the difference between successive terms. And for part C, you need to determine the rules that generate the sequence. I give you 1 minute to try. By now, you should be able to apply that formula by yourself. Okay, so I give you 1 minute to try. Okay, now, so we try to figure out the difference between the terms. So the difference is plus 5, so 11 plus 5, it is 16. And for part A, the answer is 16. Okay, calculate the difference between successive terms, and the answer is 5. And C, determine the rules that generate the sequence. As you can see here, we have common difference, therefore the sequence is a linear sequence. You can apply the formula to find out the linear sequence, which is un equal to dn plus c. For the first step, you need to find out the value for c. So here I'm choosing the first term, which is the un is 1 and it is term 1, therefore n is 1. D, the difference is 5, so substitute 5 here, and we only have c as unknown here. Okay, 1 equal to 5 plus c, and here we need to remove that 5, so we need to subtract both sides by 5. So c equal to 1 minus 5 and c equal to negative 4. Therefore, the rules that generate the sequence is un equal to 5n minus 4. Don't forget to change that d into 5 and that c into negative 4. And the final answer will be un equal to 5n minus 4. Next, example 9. A sequence has first term 20 and the difference between the term is always 31. Always 31. The difference between the terms is always 31. For part A, you need to state the rule to generate the terms of the sequence. And for part B, you need to calculate the first 5 terms of the sequence. In this example, you are not given the list of sequence here. You only given the first term, and you only given the difference between the terms is always 31. So how are you going to find out the rule to generate the terms of the sequence, and how are you going to find out that B? I give you 1 minute to try. Okay, now, so we can use the first term 20, and we know that this is linear sequence because it states the difference always 31. So it is a linear sequence. And we apply the formula to find C. The only choice is 20. So 20 is the first term. N is 1 and un equal to 20. And we figure it out, we find out the value for C. So by now you should know why I put 20 minus 31. If you're still confused, you can ask. Alright, so C equal to negative 1, and the rules to generate the terms of the sequence is un equal to 31 and minus 11. Okay, and for part B, you can apply the formula here, the rules here to get the terms, or you can write down, you can use this formula. So the first term is 20, so plus 31, you will get 51, and then you plus another 31, you will get 82, and then 82 plus 31, you will get 113, and then the last terms, 113 plus 31, and the answer is 144. Okay? Moving on with the integer sequence. An integer sequence is a sequence of integers, and this kind of sequence is actually varieties. Okay, there's a lots of different types of sequence of integers, and some of example that we mentioned in our notes will be this sequence. The first one, square number sequence, and the second one is cube number sequence. And both of these square number and cube number sequence you already covered during your year 6. And for now, you should know the general rules of the square number will be n square, and the general rules for cube numbers is n cube. Okay, in exam if you see this kind of terms, so please uh please remember about square number. Okay, when you see the terms are 1, 4, 9, 16, 25, 36, 49, and please remember that this is the terms for square number sequence. And if you see the terms in the sequence are 1, 8, 27, 64, 125, please remind yourself these are the terms for cube number sequence. The other type of integer sequence will be Fibonacci numbers. And the rules for these Fibonacci numbers actually adding the two previous numbers to get the next term. Okay, like here, if you see the terms are 0, 1, 1, please remind yourself this is Fibonacci number sequence. Okay, and to apply this rule, we add both of these terms to get the next terms. So 0 plus 1 will give you 1. 1 plus 1 will give you 2. 1 plus 2 will give you 3. And then the next one, it should be 2 plus 3 will give you 5. And then 3 plus 5 to give you 8. And then 5 plus 8 to give you 13. So this is the rules for Fibonacci number. I repeat myself, for these Fibonacci numbers, you need to add the two previous numbers to get the next terms. Now, let us try the examples. So here we have example 10.1. Write down the next two terms, and we have 3 questions here. I give you 1 minute to try. Okay, now for part A, we have 2, 4, and 6. So the first thing that you can do for sequence questions, you try to get the difference of the terms. Okay, difference between the terms. Like here, how to get 4? You add 2. Okay, and then how to get 6? You add 2. So if you can see here, we have common difference. Therefore, this is linear sequence, and we continue add 2 to get the next term, which is 8 plus 2, and which is 10. if you're asked to get the rules, and the rules is at 2, or you can apply the rules of linear sequence, okay, linear sequence, and then to get the formula, and that one we're going to cover this one at 2, and the next one we're going to cover in our next subtopic. Okay, and here we have 1, we have 4, we have 9, we have 16. So for this type of sequence, we cannot do as what we did for our part A. And please remind yourself, for part B, it is actually a square number sequence. And the first one is 1 square, which is 1, 2 square, 4, 3 square, 9, 4 square, 16, and then 5 square, 25, and then 6 square is 36. If you're asked to get the rules, and the rules is n square. And for part C, we have 0, 1, 1. So if you see this kind of terms in a sequence, please remind yourself this is about Fibonacci number sequence. Okay. So what is actually Fibonacci number sequence? We add both of the terms to get the next terms. Like here, we add 0 and 1 to get 1 for the third terms. This one is the third terms. And then to get 2, we add 1 plus 1 to get 2. And then the next term, 1 plus 2 to get 3. And then the next one, 2 plus 3 to get 5. And then 3 plus 5 to get 8, and then 5 plus 8 to get 13. Then if you're asked to get the rules, and the rules is xn minus 1 plus xn minus 2, or you can say add the two previous numbers to get the next term. Okay? Now, still example 10, but part 2, fill in the missing numbers. We have two questions here. I give you 1 minute to try. Okay, now for part A, the difference between the terms is -4. And if we try to get the difference between -12 and -8, still -4. Okay, so the difference for this sequence is -4. But be careful, for this part, we are moving to your right. Okay, but to get the value for the missing terms here, to get the value for missing terms here, you need to do the reverse for it. Okay, so instead of -4, it is +4. So -4 plus 4, remember your integers, and the answer is 0. And then 0 plus 4, the answer is 4. And then if you want to make sure, you can try +4 and you will get 8. Okay, and if you are asked to get the rules for this sequence is subtract 4. For part B, we have 16 and then we have 48. And the first term, you need to multiply by 3 to get the next terms, which is 48. And then if you realize the number is decreasing for your term 3. So if decreasing, it is impossible for you to multiply. And the possible way is divide. Okay, so 48 divided by 2 will give you 24, and then again 24 times with 3 will give you 72, and then divide by 2 will get 36. You can try multiply it by 3 and you will get 108, and then you can try divide by 2 and you will get 54. Okay, and if the question asks you about the rules, so you just explain the rules, right? The rules here: first multiply by 3 to get the second terms, and divide by 2 to get the third terms. That's it. All right. Now, the last example for 1.9.2, example 10, part 3, write down the 7 and 10 terms of the number patterns. Use a calculator to check your answers. For part A, I want you to try first. I give you 1 minute. Okay, now, so first find the difference. The difference is plus 5. So here we have common difference. And if it is common difference, it is linear sequence. So you can apply the rules of linear sequence. Okay, like in 1.9.1. So first you need to find the rule. So the rule is 5n plus 8. After that, you can substitute you can substitute 7 to that n, and then substitute 10 to that n to get the 7 and 10 terms. Okay, so here we have the 7 terms already, and the 7 terms is 43, and then the 10 terms, we change that n into 10, simply like that, and then the answer is 58. Okay, and repeat the same things for part B. You get the difference, and the difference is negative 60. And here, the D here, we also need to put that negative. Okay, I'm choosing the first term here, 200. So n is equal to 1. So the difference is negative 60. Find out that C is 260. And then the rules for these patterns is negative 60n plus 260. And then you can use this rule to get the 7 and the 10 term. The 7 terms will be negative 160, and the 10 terms will be negative 340. Okay. Now we move to 1.9.3, generating terms of a sequence. Learning objectives. At the end of the lesson, students should be able to generate terms of a sequence given a simple rules. The simple rules that we're going to cover in this session will be terms to terms rule and general terms rule. You must know the difference between terms to terms and general terms rules. Okay. Now, S to S, the first one, identify the difference between term to term and general term. That is very important. Second one, calculate the sequence with the term to term rule is given, and calculate the sequence with general terms of a sequence rule is given. And please copy this S to S in your notes. Here will be the difference between terms to terms rule and also general terms rule. Terms to terms rule, a rule that defines the value of each term in a sequence if the previous terms are known. While the general terms rule, the general terms of a sequence AN means that for this general terms rule, the rule is given. Okay, so you just need to substitute the number of terms in the rules. All right, and it can represent every other terms in the sequence. Okay. Now let's move to the examples, and here is example 1, and it is about terms to terms rule. Find the first 4 terms of a sequence. For part A, the first term is -5 and terms to terms rule is subtract 2. Please pay attention with the statement given. If the statement say terms to terms rule, and you need to follow, okay? Terms to terms rule, subtracting 2. Okay, so -5 is given for the first term. Here is the first term. Here is the first term. So you need to subtract 2, okay, to get the another terms, which is -7. And then subtract 2 to get the next terms, and you will get -9. And then subtract 2, you will get -11. So this one is what we call as term-to-term rules. And if you're asked about terms-to-terms rule, the answer is subtract 2. Now, for part B, the third term is 17 and terms-to-terms rule is at 5. How are you going to solve this one? I give you 1 minute to try. Okay, now the third term is given 17. So the terms-to-terms rule is at 5. So if the rule is at 5, that means when we move onwards, okay, like here. If we move onwards, then we're going to add 5. But what about backwards? Okay, so if backwards, you need to do the opposite of add 5. Okay, but the rule is add 5. Okay, so 17 minus 5, you will get 12. Then minus 5, you will get 7. And then the fourth term, you plus 5, and you will get 22. So be careful with these backward terms, okay? The rule is at 5, okay? But in here, you need to do the backward. So instead of plus 5 for the backward, you need to do the opposite, okay? So if still you add 5 from this 7, add 5, still you'll get 12, still you'll get 17, and still you will get 22. Okay, please do not confuse yourself about this one. Next, example 12, still with terms to terms rules. Use the term to term rules to make the sequence. Write the first 5 terms. And here for part A, the first term is given, which is 3. and terms to terms rule is multiply by 2. Again, I repeat myself, it is very important for you to recognize the question, what the question want. It's either the question one terms to terms or general terms rule. Okay, so you can circle the requirement of the questions. Okay, now I give you 1 minute to complete this part A. Okay, now, so first term is given 3. So we put that 3 on the first term and then multiply by 2 to get the next terms like this. So 3 times 2 give you 6, 6 times 2 give you 12, 12 times 2 give you 24, and then 24 times 2 will give you 48. Okay, next, for part B, still the first term is given, which is 81, and the terms to terms rule is divide by 3. And you need to write the first 5 terms, and I gave you 1 minute to complete this part B. 1 minute from now. Okay, sorry. Okay, now put the first term 81, and then the terms to terms rule is divide by 3. So 81 divided by 3 give you 27. 27 divided by 3 give you 9. 9 divided by 3 give you 3, and then 3 divided by 3 will give you 1. Okay, so this one is the terms to terms rule. Again, what is mean by terms to terms? It means that to get the next term. Okay, the rules to get the next term. Okay, now let's move to general terms rule. And for this example 13, a sequence is defined by the formula. So when you are given formula for the sequence, that means we call it general terms rule. Okay, and here the general terms is un equal to 3n plus 1. So calculate the first 5 terms of this sequence. So you need to use this rule to get the first 5 terms. Okay, so you just need to substitute that n into 1, into 2, into 3, 4, and the fifth terms. Okay, once you substitute and then you solve, you will get the value for each of the terms. And if you recall this topic, it relates with our evaluations of algebra. That is why the evaluation of algebra is very important. Okay, once you know how to substitute, once you know how to solve that algebra, that equation, then you will survive with your maths. Okay, like here, this is actually the evaluations of algebra. Okay, so don't forget to write your final answer. The first 5 of the sequence are 4, 7, 10, 13, 16. And then for example 14, write first 5 the arithmetic sequence using the given general terms. Whatever the statement is, as long as you are given the general terms, and just use that terms to find out, to solve that sequence, okay, to find out the terms. Okay, and here you have, for part A, you have an equal to, be careful, here we have negative 23 plus 17 bracket and plus 1. So this n you need to change into each terms, okay, like this. For the first term, a1, negative 23 plus 17, and change as 1 plus 1 equal to negative 23 plus 17 times 2, and then you will get 11. And then repeat the same thing for terms 2. Okay, just change this n into 2, and then you will get 28. Please completely copy these workings in your notes. Okay, please completely copy these workings in your notes. Don't miss any of it. And the next one, for the terms 3, you just change that n into 3, and then you solve, you will get 45. And then change that n into 4, and then you solve, you will get 62. And then you change that n into 5, you solve, then you will get 79. And your final answer will be 11, 28, 45, 62, and 79. Next, example 14 part B. No matter how complicated the rule is, the key to answer this type of questions, just focus with what you're going to substitute, and then be careful with your integers. Okay, just focus with that until you reach your final answer. Like here for the first term, you change it into 1. Okay, you change it in n into 1, and then you will get 14. Okay, and if it is paper 2, enough for you to get this, and then you calculate by using your calculator. But if you're still not confident, you can reach up to here and then use your calculator to get your final answer if it is paper 2. Okay, so for your first term, the answer is 14. Repeat the same thing for the second terms, and the answer is 18. Repeat for the third terms, the answer is 22. Repeat for the fourth terms, the answer is 26. Please copy this down in your notes. Okay, completely copy down this in your notes. Okay, don't skip any of the workings. All right, and the last one, the fifth terms. So substitute the 5 into 8, and then the final answer is 30. All right, and don't forget to complete your final answer. Your final answers, the first 5 terms of the sequence are 14, 18, 22, 26, and 30. Moving on with example 15, the term of a sequence are given by the formula un equal to at n minus 3. So you need to calculate for part A the first 3 terms of the sequence. I give you 1 minute to try. And don't forget to write down your full workings. Okay? Okay, now for first term, you substitute 1 into that n, so you will get 5. The second term, substitute 2 into that n, you will get 13. And then for the third term, substitute 3 into that n, you will get 21. Therefore, your final answer will be 5, 13, 21. Now, in this situation, for part B, you need to calculate the hundredth terms of the sequence. Okay, so how you going to calculate this hundredth term? By using that formula. I give you 1 minute to try. Okay, now for this kind of questions, you just need to substitute that 100 into n. Okay, so 8 n change into 100, so 8 times 100, which is 800, minus 3, and the answer is 797. Therefore, the final answer is 797. Same goes with this part C. This part C, you need to calculate the 20, sorry, this part C, you need to calculate the 200th terms of the sequence. I give you 1 minute to complete this part C. Okay, now, so change n into 200. So 8 times 200 will give you 1600, minus 3, and then the answer is 1597. Therefore, the final answer for part C is 1597. Now, Let's move to the final subtopic of this sequence, 1.9.4, generating sequences from practical context. Practical context means real life situation. Learning objectives. At the end of the lesson, students should be able to generate sequences from practical context and describe the general terms using words, mapping diagrams, and symbols. Our S2S steps to success. First, generate sequences from different real situation problem. And the second one, generate sequences from different patterns. Now, for this example 16, you are asked to make a pattern to solve the problem. Hannah has $49. She spent $8 each day. How much money does she have left after 5 days? Okay, here is the solutions and you need to create the patterns now. First, first Hannah has $49 and she spent consistently $8 each day. Therefore, for each of the day, you minus 8 and you will get 41. Okay, then minus 8, then you will get 33. And then minus 8, you will get 25. And then minus 8, you will get 17. And then minus 8, and then you will get 9. Therefore, she has $9 left after 5 days. Next, example 17. For here you have 3 questions. A plant that is 17 centimeter tall grows 2 centimeter each week. For part A, you need to continue the sequence. For part B, how tall will the plant be after 3 weeks? And for part C, after how many weeks will the plants be 27 centimeter tall? I give you 1 minute to try this question. Okay, now for part A, continue the sequence. Grows 2 centimeter each week, so 17 plus 2 will give you 19, plus 2 will give you 21, and then plus 2 will give you 23. How tall will the plant be after 3 weeks? And after 3 weeks, and the answer is 23. After how many weeks will the plants be 27 centimeter tall? So we stop at 3 weeks, which is 23 centimeter tall. Okay, if we continuously plus 2 for 4 weeks, we will get 25, and we continue plus 2 for the 5th weeks, you will get 27. Okay, and here I add another 1 more weeks, which is 6 weeks, and the answer is 29. But we only focus up to 5 weeks. And why? Because we want 27 centimeter tall. And the answer for part C is 5 weeks. Next, example 18. Natasha is making a patterns using matchsticks, and here we have a sequence in diagram. Okay, it's really famous in exam. Even sequence is one of the most important topics in exam. So make sure you know how to answer sequence problem. Alright. Now, the first three patterns are shown. For the pattern 1, we have 5 matchsticks. For pattern 2, we have 8 matchsticks. For pattern 3, we have 11 matchsticks. And here you need to complete the table. I give you 1 minute to complete the table. Okay, now, if you see from the patterns here, you add 3, then you will get 8. And then you add 3, you will get 11. And you can continuously add 3 to get the number of matchsticks for pattern number 4. And be careful here. The next one, we need pattern number 8. You can continuously add 3 until pattern number 8, and you should get 26. Now, example 19, we back to the practical context sequence. This practical context sequence is not really always come out in exam, but we still need to know how to answer this kind of questions. Okay, Harry has a roll of 74 stamps. He uses 7 stamps each day for 4 days. How many stamps are left? Okay, so here you need to make the patterns. I give you 1 minute to complete the patterns. Okay, now, so Harry used 7 stamps each day for 4 days. So from 74 we minus 7, we get 67. And then minus 7, you get 60. And then continuously minus 7, you will get 53. And then minus 7, you will get 46. Therefore, he has 46 stamps left after 4 days. Next, example 20. This diagram sequence is really famous in exam. You must know how to solve this kind of questions, okay? So here you need to draw the next two figures and describe the patterns in words. Okay, for the first one, you see we have 1 dot. And then for the second one, we have 4 dots. And then for the third figure here, we have 9 dots. So, what about the next figure? The next figure, if you see the patterns, we add L shape, okay, like this. We add L shape like this, right? So from here we have 4 dots and then L shape like this. So here we have this and then L shape like this. And the next one we have this one. We have this one, okay, and then sorry, I draw it first. So we have these 4 figures from the previous figure 4, and then we'll do L shape like this. Okay, that is how you detect the patterns in exam. Okay, and the final answer, to describe the patterns in words, the number of dots in each row and column increased by 1. Okay. Now, example 21, still with diagram sequence. Draw the next two figures and describe the patterns in words. I give you 1 minute to try. Okay, now for the first figure we have 1 triangle. For the second figure we have 2 triangles. For the third figure we have 3 triangles. And for 4 figures we have 4 triangles. And then for the fifth figures we have 5 triangles. Okay, so the answer is the number of triangle increased by 1. Okay, now example 22. This is exam format questions. So this is how the question subsequence in exam. So please try to answer this one. Example 22, the diagram show a series of figures formed by using matchsticks. And for part A, without drawing for the sketches, find the number of matchsticks used in diagram 5. For part B, which diagram has 34 matchsticks? Okay, I give you 1 minute to try. Okay, now without drawing for the sketches, find the number of matchsticks used in diagram 5. So from here you can read that to get the second diagram, you need to add 3. So 4 plus 3 will give you 7. So 7 plus 3 will give you 10. And then if you continue plus 3 until diagram 5, you will get 16. Okay, and now for part B, it's okay if you want to continuously uh count the number of matchsticks with the diagram like in part A, but in other methods you can use the rule. Okay, so here is the situation where you can apply the rules. If you can see here, we have a constant, we have a common difference for each of the terms. Okay, so if we have common difference, that means the sequence is a linear sequence. So you apply the linear sequence. You'll take this term 1, which is 4, and the difference is positive 3, and this is term 1, so n equal to 1, c is equal to 1, and the rule is un equal to 3n plus 1. But do not stop up to here, you continue. In here, it's not about finding the n. From here, it's not about finding the un. Okay? Here, the problem is you need to find that n. Okay, so this 34 is un. So you complete the solutions and you should get n equal to 11. Therefore, the final answer is 11. Next, example 23. The table shows a series of figures of shaded and unshaded boxes. So you need to be careful with shaded and unshaded boxes. Draw and complete figure 4. So you complete the figure 4 and you shade each of the side here. Okay, and at the bottom here, you alternately shade the box. Okay, like here, shaded, unshaded, shaded, unshaded, and so on. Alright, and then for part B, find the value of m and n. So m for the figure 4 and n for figure 4. And if you see the patterns here for number of shaded box, how to get 6? It is 3 plus 3. So it will give you 6. And then you plus 3 will give you 9. And then you plus 3, then you will get 12. And m should be 12. Okay. And for the number of unshaded box, from 1 to 3, we plus 2. Okay. And from 3 to 7, we plus 4. And then for 7 to n, we plus 6. Alright? And therefore, m equal to 12 and n equal to 13. Okay? And please copy this down in your notes, the workings here. Now, for part C, without drawing further sketches, find the number of shaded box in figure 8 and shaded box in figure 8. Now, for this part C, the question not expecting you to draw the further sketches, but still you can use the diagram here to help you to answer the questions. Okay, so if you continuously plus 3 for the number of shaded box, you will get 15 plus 3 18 plus 3 21 and plus 3 and you will get 24. Same goes for the unshaded box here. When you plus 8, you will get 21. When you plus 10, you will get 31. When you plus 12, you will get 43. And when you add 14, you will get 57. Therefore, for C part 1, the answer is 24. And C part 2, the answer is 57. Okay. This is also exam format questions. So, it's not difficult, but you need to be careful. Now, Last example before we stop. Example 24. I give you 1 minute to complete this question. Okay, now. Sarah's fish tank is leaking. At 6 p.m., there are 21 liters of water in the tank. At 7 p.m., there are 18 liters. And at 8 p.m., there are 15 liters. For part A, how many liters of water leak out each hour? So, from 6 p.m., it is 21 liters. 7 p.m., it is 18 liters. So, minus 3 by 3 liter leak for each hours. So if we continuously minus 3, you will get here 15. So the patterns here, we can see that the water leak 3 liter for each hours. So continuously minus 3 and the answer is 12 liter, and minus 3 and the answer is 9 liter. How many liter of water leak out each hour? The answer is 3 liters. How many liter will be left in the tank at 10 p.m.? The answer is 9 liters. How many hours will it take for all the water to leak out? So keep minus 3. So by 11 p.m. water left is 6 liter. And then keep minus 3 by 12 a.m. water left is 3 liter. And then continuously minus 3 liter, and then by 1 a.m. we have 0 water left. Okay, 0 liter left, no water left at all. Okay, so that means by 1 a.m. all the waters already leak out, and the answer is 7 hours. Be careful, it's not about asking the hours, it's asking about the duration. And when you calculate, it is about 7 hours to make sure all the water to leak out. Alright, so this will be the final example for sequence. Don't forget to complete your notes with workings and complete your worksheet. Okay, as usual, we will end our session with reciting dua. Thank you so much, and Assalamualaikum warahmatullahi wabarakatuh.
Doa selepas belajar. Bismillahirrahmanirrahim. Allahumma inni astaudi'uka ma 'allamtani fardudhu ilayya inda hajati ilaihi wala tansani ya rabbal alamin. Ya Allah, sesungguhnya aku menitipkan padamu ilmu-ilmu yang telah engkau ajarkan kepadaku, dan kembalikanlah kepadaku sewaktu aku memerlukannya kembali. Dan janganlah engkau lupakan aku kepada ilmu itu, wahai Tuhan yang memiliki semesta alam. Amin.